So in this video, we want to sort of seed some ideas of how we can, best organize our workflow in a sort of logical way that it's easy to go back and change things and iterate and set it up in a way where it's repeatable and auditable and understandable and all that sort of thing. So I mean that's one of the big challenges with scripting is making things simple, neat, concise, and easy to change. Okay, so I've got a predefined code blocks here, and I'm just going to go through them and just walk you through what I've done here. Okay, so we've loaded the data again. Just loaded that, converted it into data. We've got that topo. Just had a little preview of this. Now, one of the very important steps and very useful steps in RMSP is setting up a domains object. Mapping out the numeric codes to a string, giving them specific names. And that allows you to plot those, make nice plots where it's showing what those names are, so you immediately can produce figures which are ready for technical reports or ready for public disclosure and that sort of thing. One particularity that I want to talk about here is that I've actually ordered things backwards here according to my coding, and I did that deliberately. And that's because I've actually ordered things from youngest to oldest. So we have the overburden, which is code number 5, which is actually the first one, and granite, which is code 0, is the last one. And that's important because when we're looping through things, we're actually looping from youngest to oldest, and that's the way our geologic sequence works. So it's a good way to set it up. Another useful thing is to set up a default kernel, so default variogram parameters. Because a lot of the time you're going to be using the same parameters throughout. In geological modeling, your variogram parameters can be determined experimentally, from the actual points. But oftentimes it'll relate to data spacing or the size of grid, or tuning it based on validation, like cross-validation. How well are you actually estimating your contacts? Okay. And then you might decide to make some custom kernel arguments. So in this particular case, I know that the dike is sort of the swarm of dikes, which is striking towards 45 degrees, and it's got a high anisotropy in that direction. So I've done a bit of alteration to those arguments. I've also set up a snapping kernel. So this will be what's going to be controlling our snapping. So here I've given it a range of influence of 50 meters. And the only real difference between our default kernel is probably that range. They've got a much longer range, but they're both isotropic. Then it's useful to initialize some RBFs. So now that we've defined these custom arguments, most of them are going to be using the default arguments, but you might want to break out some of those custom arguments. So in this particular example, I'm looping through the different rock types, just assigning the arguments to the default arguments. In the case where I want something different, I check to see if that domain has its own custom arguments, and then I would assign those custom arguments to it. And then I set up an RBF estimator and just add those arguments with the star arg, so that star is basically just going to expand the arguments out. So num structure will equal 1, nugget will equal 0. So it's a very nice little concise way of doing it. Then we can set up some modelers now that we've defined those RBFs. So we could start by just doing a list comprehension, and we just say, okay, well, most of these I'm actually going to be using contact surface modeler, so just assign it to all. And then I could go in and define some specific ones. So for dike, I've said let's make that a geosurface modeler, and for massive solvent, we'll make that a vein modeler. And then what I might want to do is then set up my estimator. You don't have to set your estimator. If you run these things, that it will define its own parameters, so its own kernel, which will be estimated, and that will be estimated from the extent of your data. But it is a very good practice to actually set your RBF parameters so that you are in control of what is happening. And in this case, I'm also setting my snap parameters to the models at that point. Okay. A very, very nice thing about Python is you can automate the selection of categories. So when we're selecting contacts, or when we're producing sign distance data or anything like that, we needed to follow a couple of rules. And in this particular case, for this deposit, I want all of my lithologies contacting all the older lithologies. And then as you move down, you'll start ignoring anything that's younger, because that younger lithology is cross-cutting. So if you look at our overburden, we have overburden contacting everything. But then if we look at our dike, there's no overburden on the list, because the overburden is cross-cutting that dike. So a nice little loop to just define our inside categories and our outside categories. And then we can go and start adding data to our modelers. So this is doing exactly what was done above. This was just basically to show what's happening there. And then what we can do is we can go through here, and we can first of all, in this particular case, I'm saying, well, okay, if it's a surface model, I'm going to need sign distance data. So let me calculate some sign distance data using those inside categories and outside categories. The column I'm going to be using is that rock type column, which I defined up above. And then I can add that data, and I'm defining the field which is going to have the sign distance data. I've decided to snap, and I'll put a boundary filter on, basically saying that if everything's outside of the boundary of this particular model, it's not going to use that data. Then for the contact surface modelers, whenever something is a contact surface model, I'm basically just going to extract contacts from that data. Again, just inside and outside categories. And in this particular case, I'm looking for the footwall contacts. So the contacts below, because I'm going from youngest to oldest. Okay. And then we have our, then I'm going to add that data. I also want to snap to it, and also got that boundary filter. And then lastly, for the modeler, we can provide the interval data directly, and providing that field, the inside category, snapping true, boundary filter. I've actually saved this point data out so that we can have a look at it into a dictionary as well. So that's also a pretty good practice, so that we know what data was used during the process. Then we can define our geological sequence. So the first step was to say, okay, well, the last name, which was the granite, will be my background name. And then I can set the topo, and I loop through everything except for that last name. I can set my arguments that I want for adding my model. So in this particular case, my model is going to be this modeler based on that rock code, and then I just give that name is that domain. And if it's a surface model in this particular example, I've decided that I'm going to set my boundary filter, which is one of the arguments, to true, so that it filters out data beyond the extents of the model. Okay, so then I can have a look at my my chronology. Everything looks fine, and then I can just go and extract the solids, but I just want to pay quick attention to this. So I provided my grid there with a buffer of 20 on the spatial expense of the data, block size 10. But here I've provided that rock DOMs domains, and this is pretty neat because now when I extract that solid and view it, you can see all the colors are what I basically want it to be, and you can see we've got all our rock types honoring all of the relationships that we defined earlier on. So that's very useful. So that concludes sort of the introduction videos to geological modeling. In subsequent videos, we're going to go through each specific or class and modeling class and look at all the options that they have.